Hello, and welcome to today's webinar. My name is Lisa Shaw, the Digital Specialist at SICK. SICK is one of the world's leading manufacturers of sensors and sensor solutions for industrial applications. Today, we are presenting a breakthrough in automated print inspection presented by Carl Lewis. Just a little housekeeping before we get started. Our recording of this training will be emailed to you following today's presentation. Also, feel free to ask questions at any time during the webinar by typing your questions into the Q&A section in your control panel. We will take time at the end of today's presentation to go through as many questions as time allows. Now, without further ado, we'll turn our time over to our presenter. Carl is the Solutions Engineering Manager for Vision Solutions at SICK. He has been in the industrial automation industry for over 22 years and has nearly spent 4 of it at SICK. Carl, please take it away.
Thank you, Lisa. Good morning, everyone. Wonderful introduction. As Lisa said, I'm here today to cover a few topics, mainly the SICK Autocoding partnership, focusing on print inspection considerations. We'll be having an introduction to Foresight, which is a breakthrough in code quality. We'll look at solution examples, and there'll be time for open discussion at the end. So just to set a little bit of context and look at the problem from a high level, food manufacturing requires proper coding management and packaging verification. So according to the FDA, there were 137 product recalls during 2018 due to misbranding and undeclared allergens, all classified as Class 1 recalls, where under FDA regulations, there is significant risk to health. So fairly large problem. According to the FDA, almost 30,000 people go to the emergency room each year with severe food allergies, and an estimated 150 to 200 Americans die each year from those allergies. According to Duluth study on recall execution effectiveness, a food recall can cost in total up to $10 million or more. They also found that on average, a company's stock price declines up to 22% within 2 weeks after a recall is announced. Retailers have been focused on codes of practice for coding and labeling for a number of years. Many global food retailers have implemented codes of practice covering manufacturing standards to improve food safety and brand protection. These codes of practice cover the areas of coding management and packaging verification. So there you can see on the right-hand side, I have 2 products here, and my goal is to verify that my package has been printed with the correct information, date and lot code being a typical information that's printed on packaging. Despite the many manual or semi-automatic checks undertaken by food manufacturers, retailers have still experienced significant food safety issues. So a lot of times, companies will try to implement semi-automatic checks and manual checks, but still not solving the real problem of mispackaged goods and incorrect or absent date codes on products. Control of allergens remains critical throughout the labeling and packaging process and requires consistent monitoring. And finally, food manufacturers are being mandated by global retailers to meet higher standards as defined in their codes of practice. So that's the problem that's been identified, and SICK has a solution to solve the problem. And it's our partnership with Autocoding Systems. At the end of 2018, SICK and Autocoding Systems signed a worldwide reseller agreement. It really formalizes the relationships that has grown over the last decade in Europe, has extended to the US, which sets a framework for further innovation of a mutual solution. provides better support and services framework for our client base, and it's a unique partnership that brings leading sensing and identification companies together with a proven packaging workflow and validation software. Provides customers with a solution to reduce rework and waste, improve line availability, efficiency and quality, and ultimately help to prevent product recalls. So essentially, SICK has partnered with Autocoding over the last 10 years and developed a solution, a mutual solution, to solve a pervasive need in the marketplace where customers want to verify and validate the consistency of print verification on packaging. So what does that all mean? So SICK and Autocoding has a solution to bring together specific modules on a typical packaging line, and here are some of the modules that you'll typically see. So things like coding automation, packaging verification, integration to customer services, automatic print inspection, 3D inspection solutions, pallet labeling, line performance reporting, paperless quality. So all these things are brought together with a software module that tells a story about a customer's line, and we're basically optimizing performance. So today we're going to be talking about coding, labeling, and packaging errors. So the items here that I have highlighted in bold are the items we're going to be focusing on. So we're going to be talking about how we address the wrong date code entered into a printer, avoiding human error, using a master data message from an ERP system as an example, a coder failing to print, missing codes, or inkjet print consistency. So if you think about a basic application, we want to make sure that the right code is on the right product and the information that's printed is correct and is legible. So here's an example. So on the right-hand side here, I have an image of my product. I have 29th of August here, and I want to make sure that that date is correct. I also want to make sure it's not skewed on my product. So I want to make sure that the right product is in the right packaging with the right date. And those things can be accomplished with the solution that we have with Autocoding. So let's take a look at the requirements for OCV and OCR, just reading or verifying this text, 29th of August. So typically companies have implemented OCV, so OCV and OCR. OCR, optical character recognition, is a comparison to a database of trained alphanumeric characters, and OCV is verified characters against a predetermined character set. So the difference between OCR and OCV is with OCR, I have a database of trained characters, and OCV, I'm telling the system what is going to be read each time. So I know that the character is 29th of August, and that's all that the system will verify to. If I don't know what the character set is going to be, I have to train the complete alphabet and 0 to 9. So OCR has always been challenging, and there are a number of industry standard rules of thumb that I would need to consider when I implement an OCR or OCV solution. And I've noted some things here. So things like stroke width of smallest character should be 3 pixels wide. So if I think of this stroke here of my character, I want to make sure there's at least 3 pixels across my character. The characters should cover an area of 20 to 25 by 20 to 25 pixels. So each character should have a surface area of that amount of pixels. the spacing between characters should be at least 2 pixels. Okay, so 2 pixels between each characters to be able to segment those individual characters. The bold font style is recommended. Obviously, to create contrast, if I can control the amount of ink that I'm dispensing on my product, that's going to help me be able to verify the text that I have. Positional variables controlled, so I want to make sure that I can control the rotation and scale of my string of characters. You know, I want to control the amount of change in perspective in the z-axis as well. So I don't want those things changing each time. I want to be able to handle confusion pairs. So if you look at these sets of characters, so B, 3, and 8 are very similar to each other. So I want to be able to handle those. An I and a 1, a G and a 6, a 0 and an O, a 6, 9, and 8 all look very similar. So my OCV and OCR solution should be able to handle those confusion pairs. I should be able to adapt to low contrast. So obviously I have my bold font style, but I should be able to adapt if my contrast changes, if the amount of ink does reduce, okay? And obviously there will be some skew. I should be able to adapt to that. What about confusing background? That may occur, so I should be able to adapt to that. And also the aspect ratio may change. So all those things are things I should consider when deploying a typical OCR or OCV solution. Now, they have always been challenging for companies, require a specific skill set. Usually a vision engineer would be needed to deploy one of these systems. And just going a step further, companies will typically suggest using a standard font or train font through images. So it could be that you start with an OCR font. So here is an OCR font. So the camera knows exactly what each character looks like and can train by those, and is trained by those characters. Alternative, as I said, is training images of characters. Now, you have to train the complete alphabet, 0 to 9. It can be done, but takes time. And the goal of a typical OCV and OCR application is to achieve 99.99% correct read rate. Now, this is 1 in 1,000. So to get to that level of performance, the things that I mentioned in the last slide are very important. And there are a number of influencing factors, i.e. print quality, the application conditions. You want to make sure they have consistent lighting, the font style is consistent, and you want to be able to handle the confusion pairs. Lighting, as I said, is important. Ideally, the lighting should yield a binary image, white on black background. So that's going to accelerate the processing. So with all those things, there is a cost of ownership when packaging, new packaging is added and packaging is changed over. And that typically requires an experienced vision engineer. All these things have been done in the past, but have typically required a certain level of cost of ownership of the solution because it needs a high level of competence from an experienced vision engineer to accomplish a goal of 99.99%, 1 in 1,000, to consider all these items that I mentioned. Now, let's talk about the Foresight Solution. Now, this is a innovation from Foresight and SICK, and with our partnership with Autocoding, this enables us to provide a dedicated inspection solution for coding, marking, and label printing inspection. it means all those items that I mentioned in the last few slides are no longer needed. This truly is an innovation. So it's an automatic setup. So no fixturing, no teacher fonts, no regions of interest are needed to be optimized. The inspection is tolerant of natural variation of code location and background artwork. There's a direct connection to a printer. So the correct printer message is already known to the camera. So we're actually approaching this problem differently to other companies who focus on what has made it to a package. So since we're taking the problem back to the printer, we're verifying the text once it gets onto the package. We're able to remove the amount of training that's needed. So no fixturing, no teacher and fonts. We don't need to optimize a region of interest. That's all done automatically because of that direct connection to the printer. No software or PC required. Application is installed directly on the camera and set up via a web-based UI, so it can be connected and accessed through a tablet, a phone, or through a PC or a line-side HMI. There's also the ability to achieve a greater inspection depth. So it enables you to select appropriate levels of inspection. So if you're only interested in simple code presence, through to full OCR, there are a number of options available. So here's the typical connectivity of a Foresight application. So the Foresight app or application resides on a camera. So this is a smart camera, so all the processing is done here, and there's a user interface. The camera is actually connected to a printer, so it gets its message from a printer. It's connected to the same Ethernet network as the printer. So, you know, inkjet printers or thermal transfer or laser printers, and the camera is looking at the date code here and verifying this. It can also read the 2D barcode. And you can see here that in my UI, it said that it's a good read. So this is the typical setup. The key from this slide is the camera takes its message directly from the printer and knows exactly what should be printed on the packaging. And the camera verifies according to that. So I mentioned before there are different options depending on what is of interest. So you can start with, I just want to know something is printed. I just want to know something made it onto my packaging. I can find characters within the field of view that match the correct print characteristics. So I can know that my characters made it onto the print, made it onto the packaging, and they were printed successfully. Okay, so I'm looking at each individual character, and I'm using a set of specific printer algorithms to ensure each character is fully formed. So then I have the opportunity to make sure that the specific characters are legible. So I can detect good codes. I can also detect poorly printed characters, and I can also detect marginally printed characters as well, and all at high speed, 1200 parts per minute on select pieces of hardware. Now, if I'm interested in, I just want to make sure that something is printed and is in the right area, I can also do that. So with box inspection, I can also make sure that the characters are present and they're legible, and they're also in the correct spot in my window here. So if this is a challenge that you have, this is something that can be solved as well. So we want to make sure that the characters are parallel with the box edges. They're not skewed. Once the characters have been located, the system ensures that they're uniform, they're the expected print location and style. And we're taking this information directly from the printer. So any characters that are poorly printed, skewed, double prints, or characters that cause the print box inspection to fall outside the tolerance, they'll be rejected. Again, all at high speed, 1200 parts per minute on select hardware. And then finally, the last option is OCR or OCV. So scalable solution right from print presence up to OCR, OCV. So in this case, I want to know that the printer is printing the correct information. And this is where we read each individual character and ensure it's readable. So we have a confidence score for each character, which determines our good and bad reads. And we have a match code set directly from the printer. So just want to move on to a few features and benefits of the software. So this is the UI. So this is where we can get a little bit more information about the application, image-centric. You have the image in the middle of the UI here. And the user interface has statistics of my specific product, user login used to restrict available pages in app. So, if I want to give a user access to everything, that's also possible, but there are different levels of user login. This can be accessed and integrated into a remote web page, and you can see live images directly on a PC or on a phone or on a tablet. But this inspection page is really your user interface for making any adjustments that's needed based on the statistics you see on the right-hand side of the page. So once I understand the changes that I need to make, I can then go into my menu and make the changes I need. So as an example, if I want to change the way I'm sending images, archiving images, I have FTP option to send images to a folder on a server or on a PC for analyzing later or archiving data. Have the results page, which I showed you a second ago, which is used for classifying good, bad, read or no read. There's a digital I/O page to define what I/O is used for. That's all configured through the user interface. There's a configurations page where I save and load and delete named configurations for varying inspection needs. So if there are aspects about my application which mean that I have to change the configuration, I can save recipes in my configuration page. Foresight page, and this is where I configure the attached printer connection. So I mentioned before that Foresight connects directly to a printer, to the same network as Ethernet network as my printer. So that's where I configure my messages to influence the match string. And there's a system log page to show the tracking of events that are happening in the system. So in summary, Foresight approaches the problem a lot differently to other OCV and OCR solutions, because we're taking the message directly from a printer into a camera, and because of that, we don't need to provide a lot of training on the application. So we don't need to worry about configuring confusion pairs. We don't have to worry about changing regions of interest. The printer drivers allow for no setup or training for OCR and barcodes. Valid performance versus cost far exceeds competition. Our entry point for larger error-proofing production on the production line. So there is an opportunity to connect this to a much wider solution, autocoding solution, where we can get a message from a ERP system, take it into a server-based solution, and send the message directly to a printer. So there's no data that's added to a printer. So all of that linkage is automated. So that's essentially it. Any questions?
Thank you, Carl.